I'm going to assume for a moment that you guys sort of remember what congruent triangles are. Similar triangles are something different. Congruent triangles have the same shape and the same size. Similar triangles have the same shape, but they're not necessarily the same size. Okay? So, first place I want to start is here, because this is what it means for two triangles to be similar. If all of these things are true, then the two triangles are similar. Okay? You have to have three pairs of congruent corresponding angles. That means these angles over here are from one triangle, these angles are from the other triangle. Each triangle has one that's this measurement, each triangle has one that's this measurement, each triangle has one that's this measurement. If we were doing congruent triangles, then we would have to say that one side is equal to the other side, that AB was congruent to BC, okay, and that DB was congruent to BE, and that DA was congruent to CE. In other words, they have exactly the same size. This would be the other three things you'd have to show in order to know for sure that two triangles were congruent. Right? Congruent angles, congruent sides. Not so much with the ones that are similar, because they're not congruent, or usually not congruent, but instead, if you take the ratio of the side lengths from one triangle to the other, from one triangle to the other, from one triangle to the other, those ratios are all equal. Okay? Why is that? Well, here, if I draw this triangle, and then I draw this triangle, these are the same shape, and one of them is, let's say, twice as big as the other. What does that mean? That means that whatever the side lengths are here, A, B, and C, this is going to be 2A. This is going to be 2B. This is going to be 2C. Okay? And that means if you take this side and divide it by this side, you get 2. If you take this side and divide it by this side, you get 2. If you take this side, divide it by this side, you get 2. It's the zoom factor. Could be, if it's greater than 1, it's getting bigger. If it's less than 1, it's getting smaller. But it's the zoom factor, or the scale factor. That's what this is. Here is the trick. If you're looking at two triangles, and you're trying to figure out if the ratios are the same, you got three numbers over here, you got three numbers over there. There's a whole bunch of different ways you could put them all together. Some ways they might be the same ratio, and then if you put them together some other way, they might not. How are you supposed to know? Here is the answer. Small, medium, large. If you take the small side of one triangle and compare it to the small side of the other triangle, take the medium side of one triangle, compare it to the medium side of the other triangle, and take the large side of the third triangle and compare it. If it turns out that these ratios are equal to each other, you don't have to do anything else to prove that the two triangles are similar. Obviously, if you take the large one and compare it to the small one, and the small one and compare it to the large one, it's not going to work. So this is actually really the first step in trying to decide whether or not two triangles are similar. What's the trick here? What do you need in order to be able to do this? You're going to make this work, you need 6 numbers. You need to know every side length. You need to know this one, this one, this one, this one, this one, and this one. If you have all 6 side lengths in your problem, and you set it up like this, and the numbers are the same, you are done. Because that's called side, side, side similarity. What does a proof of that look like? Looks like this. If you have all 6 sides, then that means you have AB is equal to something. You have BC is equal to something. And you have AC is equal to something. And then the other triangle, you have DE is equal to something. EF is equal to something. And DF is equal to something else. Now, if I've done this so that this is small, this is medium, this is large for each of the 2 triangles, that's going to mean that I have these numbers already set up where they need to be. But basically, this is just given. Now, if I look at these ratios and it turns out that AC over DE is equal to AB over EF is equal to BC over DF, if those ratios are all the same, and you put whatever number that is right here, blah, blah, blah over blah, 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 those are proportions. And that's all you got to write. Proportions.
That's the reason?
Yeah, proportions. That's what they are. They're proportions, and it works. Now, the only thing left that you have to do is to write the similarity statement. This is slightly tricky because you have to do this in such a way that AC and DE are in the same positions in the explanation. So, in other words, if I do A, B, C, right? Let's just do that. A, B, C. Well, AB corresponds to EF, and BC corresponds to DF. Well, I can't put F twice. This is going to have to be E, F, D. Okay? Told you it was tricky. Yeah. BC and FD correspond because BC and DF corresponded. They're just backwards. The same thing. So in other words, the triangles now, the way I've written it, are going to look like this. A, B, C, right? D, E, F, not to scale. But what this says is the angle here at A is going to be congruent to the angle at E. The angle at B is going to be congruent to the angle at F. And the angle at D, which is here, is going to be congruent to the angle at C over here. If I were looking at this, can I use side, side, side on this? I don't have any sides. Even if I had 5 sides, right? Even if I knew the side length of this one, this one, this one, this one, and this one, that wouldn't be enough. You need 6. But if you have 6, you can be done in about 60 seconds. Small, medium, large, check to see what the ratios look like. If they're all the same proportions, write this out, write S, 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 similarity, and you're done. Right? If you're in this situation where you're given all 6 sides, you don't even have to look at the angles. That's the key. If you can show this, you don't have to worry about any of this. This will take care of itself. Okay? Now, if you have a case like this, you don't have any sides at all. So you're not going to be able to show me any of this stuff. If you can show me 2 pairs of angles that are congruent, two corresponding pairs of angles that are congruent. That's enough. You don't even have to look at the third. Right? You know why? Because they all have to add up to 180. If these two are the same as these two, then whatever it is that adds up to 180 is going to be the same here too. So you just have to look at two of them. Just two angles, that's all it takes. Now here, as it turns out, do we see any congruent angles here? What angles? A and C. Angle A is congruent to angle C, and how do I know that? Yeah, it's given. Now, here's a clue. This is important. This will be enough. This would be one of those things like misspelling triangle, right? This would be enough to totally make you not pass the standard. Okay? You are allowed to call this angle C. And you are allowed to call this angle A because there is only one angle at this vertex. Here, on the other hand, there's a whole bunch of angles. And if you call that angle B, I don't know what you're talking about. That's enough to not pass the standard. So if you wrote here angle B is congruent to angle B, I don't even look at the rest of it. You're done. Okay, so now, if you're not going to use one letter, what you actually need to do is use three letters, not two, right? Because what you have to do is you have to write something that will let me trace to figure out what angle you're talking about. ABD, that would be A, B, oh, okay, so you mean this angle here. Right? If you just say AB, I still don't know. Right? I need 3 points, A, B, D. Basically, what you're doing is telling me how to trace it so I can find what angle you're talking about. And that's going to be congruent to angle CBE, right, which is CBE. And why is that? How do I know they're going to be congruent? Nope. They're vertical angles. Uh-huh. Now, when you're thinking to yourself, wait a minute, why do I have to remember what was last year? If I'm taking geometry B, why do I have to remember any of the geometry A stuff? This is why. Because this was last year. And if you don't remember this, how are you going to explain to me how you know these two are congruent? You can't. Okay? But if you do this, guess what? You're done. Because triangle ABD is similar to triangle. All right, now let's see. A, that angle was the same as C, so that has to come first. CBE. And how do I know? That's angle, angle. Okay? So it's two different ways to do a proof based on what you're given. If you're given all 6 sides, you can do side, side, side. If you're given or can figure out 2 angles, you can do angle, angle. But now, what if you're not given 6 sides and you're not given 2 angles? There's one more shortcut that works. If you have 2 triangles, okay, and you're given this side, and this side, and this side, and this side, and this angle, and this angle, okay? And it only works if you have an angle and the 2 sides that make that angle. So in other words, if I had this angle, this side, and this side, that wouldn't work. But if you have a side, an angle, and a side, that correspond to a side, an angle, and a side, if you can show me angle F is congruent to angle E, however you show me, whether it's because it's given or because they're vertical angles or whatever, if you pick the small one of these and compare it to the small one of these, let's just for the moment say it's A over C, if that's equal to B over D, this would be the large one and the large one, if those two things are true, then triangle BFA, so I started here, went down the small one to the angle that's congruent, and then went back across. So I need to go down the small one to the angle that's congruent and then back across. So that's DEC. Triangle DEC, right? The answer to this would just be proportions. Right? You would have to say that you were given A, B, C, and D. You'd have to say given up here. You'd have to explain how you know that these two angles are congruent. You'd have to show that these two proportions are equal. And then that means that these two triangles are side, angle, side similarity. Those are the only three kinds of problems you can get. Okay, that's it. It's the only three ways you can show me that two triangles are similar. A couple of quick heads up things here. Sides are never similar to other sides. Doesn't mean anything. Angles are never similar to other angles. Similar means same shape, not necessarily the same size. Well, if the two angles are the same shape, they're the same size. And if, I don't even know what it would mean for sides to be similar. They're either the same size or they're not. They're all just sort of straight lines. So you can't say these. This doesn't make any sense. And when you're looking at this, if you're trying to prove similarity, you can't tell me that AF is congruent to CE, because they're not. They have a proportion that is the same as EB to ED. I'm going to walk through this exactly the way I just told you you could. And that is, first of all, if I have 6 sides, I can do side, side, side. So how many do I have? I got 1, 2, 3, 4, 5. Oh. Side, side, side is not going to work. Done. Don't even try it. You don't have the stuff. Angle, angle. Well, I've got this angle is congruent to this angle. These triangles are not connected in any way, so I can't use any of the fancy stuff I know, like, I don't know, like alternate interior angles on parallel lines or vertical angles. That's all I got. I got one angle. So I can't do angle, angle. The only thing left to try is side, angle, side. As it turns out, I have the measure of this side and the measure of this side that create the angle that is congruent to the angle on the other side, where I also have the measure of this side and the measure of this side. So now how do I write all of that down? Well, first of all, over here I have AB is equal to 27. And I have BC is equal to 18. Now, this is the bigger of the two. So which one's bigger over here? 15. Okay, so I have RP is equal to 15. And PQ is equal to 10. And I also have angle ABC is congruent to angle RPQ. all of that is given. Now, I've set this up so that before I even write anything else, I can look here and see, what is this reduced to? What is this reduced to? Well, yeah.
Right, but do we have to put the measurements in? Like the one
These?
above that? Yeah.
Oh, yeah, you're going to need those, right? Because what you're going to need to show is that you've got equal ratios and a congruent angle. So here, right, you got 27 over 15. That reduces to 9 over 5 if I divide top and bottom by 3. Over here, if I divide top and bottom by 2, I get 9 over 5. That's the same number. That means that AB over RP is equal to BC over PQ, which is equal to 9 over 5. And how do I know that? Proportions. And now I have side, angle, side, side, angle, side, and I'm pretty much done. I can just trace the large side first to the angle that's congruent and back. Right? Triangle ABC is similar to triangle the large side first, RPQ. And that's all because of side, angle, side. And I have that. I have the angle here, and I have the two sides, the two corresponding sides here that are equal by proportion. That's the whole proof. That's it. Somebody asked me, well, what about the 24? I said, I don't really care about the 24. I mean, it's nice, but I'm not going to use it. Right? It's just an extra piece of information I don't care about. Okay? The other part is if you're told that two figures are similar. For example, if you're told that ABCD is similar to KGHJ, here is what you know just based on this statement. I know that angle A is congruent to angle K. I know that angle B is congruent to angle G. I know that angle C is congruent to angle H, and I know that angle D is congruent to angle J, and I know that because that's the order they came in. ABCD, KGHJ. ABCD, KGHJ. The other thing that I know is that the sides that are corresponding, AB and KG, BC and GH, CD and HJ, and then the last one, which would be AD and KJ, all of those ratios have to be equal to each other. This, right here, is what this says, without even looking at the picture. Now, what pieces of information do I have from the picture? Somebody tell me. I don't have the picture in front of me. Tell me what I got.
Angle D is 58.
Angle B is 58 degrees? D. D is 58 degrees, okay.
Angle C is 60.
Angle C is 60.
Segment GK is 24.
GK is 24, okay. What's that?
AD is 9.
AD is 9, that's over here.
DC is 8.
DC is 8.
BC is 5.
BC is 5. What about AB?
4.
Oh, I got this too?
Yeah.
Okay. And what are they asking me to find?
Oh, H.
Okay, so angle H.
HJ.
Oh, HJ. This is X? I mean, Y was the angle. Okay, so now, hey, I already know what Y is, don't I? I'm done. Y is 60 degrees. Why? Because angle A, B, C, and D are congruent to angle K, G, H, and J, because that's what this says. Over here, take a look. I got a number on the top and the bottom, right? I got them both. That means I know what the scale is, right? the ratio is 1 over 6, right? And what I want is this one, which is 8 over x. I can do that. First of all, I can take the reciprocal of both sides. Then I can multiply both sides by 8. And I'm done. That's it.